Hello world, MicroCats! This video is about connecting nRF24 radio modules. We go straight to action, since there are two modules and then the STM32 microcontroller will need two. On the left there will be a controller with a display, and on the right a controller with LEDs. Each controller has its own nRF24 radio module. They are connected in the same way via the SPI interface. The touch keyboard is the input device, and the display is the indicator on the left of the microcontroller. Two buttons and three LEDs are all the peripherals of a controller on the right. We turn on the power and see how it works. The display has loaded. Let's take a closer look. Press the keys on the left controller and see what happens to the LEDs of the right controller. The red LED turned on and an inscription appeared on the screen. Press key 2 and see that the yellow LED is 1, and the inscription on the screen has become sand yellow. And the same for the third key, green LED, green inscription on the screen. Use the 4K to clear the screen and turn off the LEDs. Note that the controllers are connected by wires only by power supply. Now the right controller will send data to the left controller, also using these two radio modules. We press in turn on the touch buttons. The inscription is poorly visible. It says button 1 pressed. That's better. Click on the first button again and see the inscription on the screen. Click on the second one and see that the inscription changes. You press and turn on the buttons. The display immediately updates the current inscription. And at the same time we can control the traffic light from the left controller. As you can see, control and reception are two-way, that is, both controllers act as both a receiver and a transmitter. You press some touch buttons and see the result on another device and vice versa. Let's consider the electrical part of both controllers. For the left control unit, an STM32 microcontroller is used. ST7735 display, touch keyboard, radio module nRF24L01 connected via SPI2 interface. Additionally, pins CE, INT are used. Power supply 3.3 volts. For the right control unit, the microcontroller and radio module are used the same, with the same wiring diagram as the left control unit. Additionally, introduced two touch buttons. The indicator is an LED traffic light. We take 3.3 volts power from the left control unit or another source. Let's move on to programming. We specify the necessary header files and many interrupt handlers. Please note that one project is used for both controllers, but at the same time they work in different ways. This is possible thanks to conditional compilation and special compiler directives. You can write code in the same project for different jobs by setting a conditional compilation statement for each piece of code. In this case, follow the steps in the command to compile and flash your controllers one at a time. Here, for example, let's uncomment both directives. It is a custom handler coming in from thin air, buffer with data, their size and internal number of the receiving tube. For the left controller, show on the display that the button is pressed. Highlight the button number in yellow. For the right controller, turn on the LED or turn off everything at once. It is a custom outbound data handler to the air, buffer for data and their size. Pay attention to the data that the left controller sends. This is the same data that the right controller receives. In this way, control from push buttons to LEDs is achieved, and the received data for the left controller is the same data sent from the two buttons of the right controller. The size of the payload is limited to 32 bytes. In the main function we call the peripheral settings. More details in microlib.c file. To work with a display, you need to work with a structural object. We initialize and draw what is needed for the current task. The NRF24 radio module programmatically is also designed as a structural module. We indicate the pins for the lines CS, CE, INT and the used SPI interface. We set up our callback functions. We initialize the module and call the additional configuration functions. This is the setting of the gain, baud rate, radio channel number and checksum data. Using the addresses used, use the address of a remote device, the address for receiving confirmation from the remote device, and our own address. We configure the parameters of after repeat data in case of confirmation error. The microcontroller on the right is configured in the same way, but pay attention to the addresses, they are opposite. In an infinite loop, controllers work a little differently, but there must be a call to the listen function to switch to receive mode. The left controller analyzes the flags of pressing the keys of its keyboard and calls the drawing and answering function over the radio channel. A right controller only calls the response function. The file nrf24.h describes the registers of the radio module as well as marks for them. Definitions for advanced settings and special instructions. In addition, there are functions for internal use. This is mostly low-level code, and custom function to work with. Procedure initialization use internal function to initialize peripherals, configure interfaces, work with interrupts and DMA. Restoring default settings, checking custom data handlers. We turn on the module and after some delay we switch it to the receive mode. We are waiting for 130 microseconds for frequency adjustment. Setting up additional registers and flags, a function that must be called in the infinite main loop. Here the module switches to receive after it has transmitted data in the answer function. An additional reset of status flags takes place here. The procedure for sending data on the air. We reset the status flags and get user data. We copy them to the module, switch the module to transfer mode and transfer the data. Stop transmission on signal from interrupt, wherein signal routine is located in the ext interrupt. We analyze the status flags on the module. If the data is received, then we get the number of the receiving tube, the size of the data. We copy them through the SPI interface. We call the custom handler and reset the status flags. If the interrupt came after a successful transmission, just set the flag. If a transfer was made with an error, there was no confirmation, then we discard the packet and set the flag. That's all, see you in the next video. Subscribe MicroCat.